fabulous fourth graders. So yesterday in science, we ended with how could this device be useful? Hopefully, you came up with something along the lines of a steam engine or how cars used to travel, a water-based engine. Nowadays, we have things that can be used a little bit quicker, but I'm going to turn it back over to Doug because I want you to see what this experiment would look like if we were in school.
In today's activity, you're going to make a machine that uses heat to make a spinner spin. In the first part of the activity, you'll make a spinner and a spinning support tower. In the second part of the activity, we challenge you to use heat to make your spinner spin steadily. To do that, you're going to have to think like an inventor. Inventors experiment and pay attention to what happens. And just as important, they pay attention to times when nothing happens. Sometimes the only way to figure out why something works is to see where it doesn't work. I'll show you how to get started experimenting step by step.
All right, so we are going to skip through some of these instructions just because you all aren't going to be able to make this experiment at home. But I do want you to see what that final product is going to look like. So bear tight with me while I get us to the correct place.
In case it's helpful, here are some things we noticed. You can make the spinner move by blowing on it, by fanning it, or even by talking at it. You might find out that some words even make it spin more than others. The spinner moves because talking, blowing, and fanning all make air move. That moving air is what pushes on the spinner and makes it spin. When I pick up the cup, I do have to move it slowly to keep the spinner balanced on the pin. But once I get the hang of it, I can make the spinner move by lifting it up or by lowering it. By moving the spinner through the air, I made the air push on the spinner, and that made the spinner move. Did you notice that the spinner turned in one direction when I lifted it up, but then turned in the other direction when I lowered it? The direction of spin depends on which way the air is moving. Now, you're going to try using heat to make your spinner move. As you experiment with heat, be sure to move slowly and cover or shield your nose while you're breathing or talking. A sudden movement or breath of air can change your results.
All right, so we're going to skip through this discussion part.
If you're in a class, your teacher When you're doing question 1 on your worksheet, watch this. When everyone's done with the activity, be sure to go to the final video.
I want you all to take notice of what's happening as more candles are being lit.
In the activity, you created a heat spinner that transforms heat into movement. Your spinner started moving when you held it over something hot, like a light bulb in a lamp or a cup of hot water or a heat pack. Maybe you noticed your spinner didn't spin as much when you held it beside the heat source or below the heat source. Why is that? Well, you probably know that hot air rises. This is also why hot air balloons float. There's a source of heat inside the balloon, and that heat rises. You know, in a way, you can think of your heat spinner as a kind of chain reaction machine. Something hot, like this light bulb, makes the air nearby it hot. As that hot air rises, it pushes on the spinner. Then the spinner moves. Take a look at Hero's toy again, but now consider it in the same way, like a chain reaction machine. Step 1, fire heats up water inside the device. Step 2, water starts to boil and turns into steam. The air and steam inside are super hot. Step 3, that super hot air and steam rush out of the device through the pipes on either side, and that makes it move. At each step, energy is transferred from one part to the next, from the fire to the air and water to the container. The device starts with a source of heat and ends up with movement. Heat can cause things to start moving. So heat is yet another form of energy. Today, scientists have a special name for any device that turns heat energy into movement. They call it a heat engine. Hero's device is known as Hero's engine. Hero may have built it just for fun, but over 2,000 years later, it inspired inventors to develop a heat engine that was even more useful. The steam engine. This video shows a miniature version of a steam engine someone created out of glass, so that you can see what's going on inside. It does the same basic thing as Hero's engine. First, a flame is lit under a container of water, which starts to boil. Heat makes steam and air rise and move through the tubes. Then the steam pushes on a piece in here back and forth, which pushes on a rod that's connected to the wheel. Each time this container fills up and releases steam, it turns the wheel. Check it out. By attaching steam engines to the wheels on trains, the steam locomotive or modern train was born. This meant, for the first time ever, people could travel across an entire continent using machines instead of on foot or being pulled by horses. Using a steam engine, a trip from one side of North America to the other, a trip that used to take 6 months, now could be completed in only 4 days. And you know that's not the end of the story. Travel has only continued to get faster and cheaper, with modern forms of transportation like cars and airplanes. For example, on a train, it takes about 4 days to travel from San Francisco to New York City. But now you can fly that same distance in just 5 hours. The engines inside of cars and airplanes use other fuels instead of steam power, but they still run on the same basic idea that Hero's engine did, the heat engine. They use heat energy from burning fuel to make things move. We'll talk more about modern fuels and energy in the next mystery. Until then, have fun and stay curious.
All right, fabulous fourth graders. I want you all to head to your Google Classroom, and I want you to answer the question that is there for today. So we will see you very soon. Have a fabulous rest of your day.